Physics. So the topic of discussion is force. So define force. So force, it is a pull or push or twist of a body. That is what we call force. So that is the definition of force. So force, it is a pull or push or twist of a body or of an object. So the unit for force, it is called Newton. So force is calculated in newtons. So the symbol, it is a capital letter N. So when we are dealing with the name of a person, we always use the capital letters. Then you need to understand that force is a very good example of a vector quantity. So that is for force. So force is an example of a vector quantity. Remember that a vector quantity, it's a quantity that has both the magnitude and the direction. So force, it has both the size and the direction. So now we have what we call the effects of forces. So effects of forces. Number one effect of a force is that force can make the body to start to move. Once you apply the force to a body can start to move. So that is number one effect. So that is number one. So force can make the body to start to move. Number two, force can change the direction of a body. So a good example that we can give is we can give an example of a vehicle, a moving vehicle. So a moving vehicle can change its direction once the external force is applied. So number three, force can speed up or slow down the speed of an object. So that is another effect of a force. So the last one is force can change the size and the shape of an object. So that is the fourth effect of a force. So force can change the size and the shape of an object. So Newton's first law of motion. So what does Newton's first law of motion states? So Newton's first law of motion, it says that a body continues in a state of rest or in a uniform velocity in a straight line, provided no external force acts on it. That is what we call Newton's first law of motion. So this is what we call Newton's first law of motion. So a body continues in a state of rest or uniform velocity in a straight line, provided no external force acts on it. Example that we can give, if you leave something on the ground, you leave it there. After 7 days, you'll find that it is there, provided no one is tampering on it. So that is what Newton's first law of motion it is trying to explain to us. Okay, so this Newton's first law of motion, it is also called inertia's law. So that is Newton's first law of motion. So it is also called inertia law. So let's look at inertia. What is inertia? So what is inertia? So inertia, it is simply the property or tendency of an object that resists any change of motion. It is the property or tendency, property of a body or an object that resists any change so that is inertia. So inertia is a property or tendency of a body that resists any change in its motion. So you have to take note that the more the mass of a body, the more its inertia. Remember this example, two vehicles. One vehicle is big, the other one is small. So a big vehicle, it has more mass. So since it has more mass, it will have more inertia and less acceleration. But when you look at a small vehicle, it has less mass, so it has also less inertia and it has more acceleration. So take note of that. Newton's second law of motion. Newton's second law of motion, it states that a force acts on a body, accelerates a body in the direction of the force. And the acceleration is directly proportional to the net force and inversely proportional to the mass being accelerated. So that is Newton's second law of motion. A force acts on a body, accelerates it in the direction of the force. The acceleration is directly proportional to the net force and inversely proportional to the mass being accelerated. So this implies that acceleration is directly proportional to force and inversely to mass. So acceleration is equal to force over mass. So force is equal to mass times acceleration. Examples. Calculate the net force required to give a 3000 kg truck an acceleration of 2.5 meters per second squared. So calculate the net force. So what have we been given? Mass and acceleration. So remember that force is equal to mass times acceleration. So remember that force is equal to mass times acceleration. So all we want is force. Mass is given. So ensure that your mass is in kilogram. So mass is 3000 kg times acceleration. So acceleration is 2.5 meters per second squared. So force is equal to 3000 times 2.5. So the answer is 7,500 newtons. 7,500 newtons. That is our answer. Number 2, calculate the acceleration of the car. So this is the car that we have. We have the driving force, which is 1,600 newtons, and we have the resisting force, which is 400 newtons, and the mass of the car is 1000 kg. So the question is demanding for acceleration. So remember that force is equal to mass times acceleration. So mass we have, it is 1000 kg, and we are looking for acceleration. Do we have force? So we have two forces that are acting on the car. So in this case, we are going to calculate the resultant force. So how do we calculate the resultant force? So I'll say resultant force is equal to, since these two forces, they are acting in the opposite direction, I'm going to subtract. So 1,600 minus 400. So the resultant force is 1,200 newtons. So this is the resultant force. So that is the resultant force. So the resultant force that we have is 1,200. So 1,200 is equal to mass of the car is 1,000 times the acceleration. So in this case, I'll divide throughout with 1,000 over 1,000. So 1,000 goes. So acceleration is equal to 1,000 into 1,200. The answer is 1.2 meters per second squared. So that is our acceleration. Number 3, an object of mass 2 kg is sliding with a constant velocity of 4 meters per second on a frictionless horizontal table. The force required to keep the object moving with the same velocity. So find the force required to keep the object moving with the same velocity. So remember that in this case, velocity is constant. We have a constant velocity. So where we have a constant velocity, acceleration is equal to 0. So the force that is required, we can say force is equal to mass times acceleration. So the force that is required is equal to mass we have, it is 2 kg, times acceleration is 0. So why is acceleration is equal to 0? Because it is a constant velocity. At the constant velocity, acceleration is 0. So 2 times 0, it is 0. So force is equal to 0 newtons. So that is our answer. Number 4, calculate the acceleration of a skydiver of mass 80 kg and weighs 600 newtons. So remember that force is equal to mass times acceleration. So force is given. So force is given to be 600. Mass is given to be 80 times the acceleration. So over 80 over 80. So 8 and 80 goes. So acceleration is equal to, so 80 into 600. The answer is 7.5. So that is our acceleration. A block of mass 500 gram is pulled from rest on an horizontal frictionless bench by a steady force F and travels 8 meters in 2 seconds. Find the acceleration. So how do we find acceleration in this case? So in this case, what we have, it is time and distance. Time and distance we have. So I'll remember the linear motion equations. So I'll demand on one equation that has time on it and distance. So there it is, S is equal to ut plus 1 over 2 at squared, where S, it is distance, u, initial velocity times time, a, that is the acceleration. The distance I have, it is 8. So where there is S, I'll put 8. U, remember that a block of mass 500 grams is pulled from rest. So U is equal to 0. Is from rest, U is equal to 0. Then T is equal to 2. So 0 times 2 plus 1 over 2 times acceleration times 2 squared. So 0 times 2, that is 0, so we have 8, is equal to, so 2 squared, that is 4. So the half of 4, that is 2. So I have 2a. So over 2. So acceleration is equal to 2 into 8, that is 4. So we have 4 meters per second squared, that is acceleration. Then part B, find the value of F. So F, it is force. So remember that force is equal to mass times acceleration. So force is equal to acceleration we have, it is 500 grams. So what you have to do is you need to convert that 500 grams to kilogram. So how do we convert from grams to kilogram? So you need to divide by 1000. So 500 divided by 1000 times acceleration that we have is 4. So force is equal to this 0 goes, this 0 goes. So 5 there, it is 1, 5 there in 10 is 2. So 2 into 4, that is 2. So we have 2 newtons. That is our answer. Newton's third law of motion. So what does Newton's third law of motion states? So Newton's third law of motion, it says that for every action force, there is an equal opposite reaction in force. So that is Newton's third law of motion. So there is also what we call the upthrust force. So what is an upthrust force? An upthrust force, it is a force which pushes upwards an object submerged in a fluid. That is what we call the upthrust force. Upthrust force is a force that pushes upwards on an object submerged in a fluid. So it is also known as buoyancy force. It is also known as buoyancy force. Then upthrust force, it is greater in liquids than in gases. So upthrust force, it is always greater in liquids than in gases. There is also what we call friction force. So friction force, it's a force that opposes the motion of an object in contact with the surface. So that is friction force. So friction force is a force that opposes the motion of an object in contact with the surface. So disadvantages of friction force. Number one, it is heat. Number two, it is wear and tear. So there's also what we call centripetal force. So what is this centripetal force? It is a force that acts on a body and causes it to move in a circular motion. So circular motion in a what? In a circle. That's what it means when you say circular motion. So that is what we call centripetal force. So the formula for centripetal force, so force is equal to mass times velocity squared divided by radius. So this is the formula for a centripetal force. So we have centripetal force is equal to mass of a body, speed of the body, and radius of a circular motion. Example, a 1200 kg car turns a corner with a radius of 32 meters at 4 meters per second. Calculate the centripetal force of the rod on the tires of the car. So centripetal force is equal to mass times velocity squared over radius. So centripetal force is equal to mass is 1200 times velocity is 4 meters per second. So it will be 4 squared divided by radius 32 meters. So centripetal force is equal to 1200 times 4 squared, it is 16. So 16 over 32. So centripetal force is equal to 1200 times 16 over 32. So the answer is 600. 600 newtons. Number 2, a boy has a ball of mass 100 grams tied to the end of a string. He swings a ball at 7 meters per second in a circle that has a radius of 1.4 meters. Calculate the centripetal force. So remember that your mass should be in kilograms. So you need to change from grams to kilogram by dividing with 1000. So 100, which is our mass. So 100 over 1000 times our speed is 7. So it will be 7 squared over our radius is 1.4. So centripetal force is equal to 100 divided by 1000, it is 0.1. So 7 squared, it is 49 over 1.4. So centripetal force is equal to 3.5. So 3.5 newtons. So thank you very much for watching. Don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions.